So for a question like this, we're going to have to use something called implicit differentiation. And we're going to have to set up a dy dx. We have to identify each one of these individually. So when we derive x, we're just going to get 1. That's pretty straightforward. When we derive 3y, we have to understand that we're deriving with respect to x. So we can do 3, the derivative of 3y was 3, but then we have to tack on our dy over dx to keep it in terms of dy dx. So then we move over here, and we're going to have to use two different product rules. So for the first one, we're going to say, well, the derivative of x is 1 times y to the 4 plus, and then the derivative of that is 4y cubed, and we have to tack on our dy over dx, and we're going to say times x. Now for this one, we're going to say, well, the derivative of x squared is 2x, and then we're going to add the y, and then we're going to say x squared, and the derivative of y is 1, but we have to add on the dy over dx. Now it's important that you get every term with a dy dx on one side and everything without on the other side. So let's bring this 3 dy dx on this side. So let's write this out. We're going to have y to the 4th plus 4y cubed dy dx times x plus 2xy plus x squared dy dx, and then we're going to bring over this and we're going to say negative 3 dy dx equals 1. So now we can bring this product and this product onto the other side as negatives. So we'll write 1 minus 2xy minus y to the 4th. And then we're going to keep whatever's remaining. So 4y cubed dy over dx. And we're just going to put the x there because that's there. Plus x squared dy over dx minus 3 dy over dx. Now, what we need to do is we need to factor out the dy dx out of every single term. So if we divide out dy dx, what do we have left? We have 4xy cubed plus x squared minus 3. 1 minus 2xy, y to the 4th. And then now we simply just divide by this whole thing. And then finally, this is our final answer, 4x y cubed plus x squared minus 3. So those will cancel. This is our final answer. It's what we wanted. And then this is our final derivative.